Good afternoon. I'm very delighted to be here today to share with you our research on green colorants. So you might wonder, or you might not, why we're particularly interested in this topic. First of all, green is a very captivating color, one that breathes life into the very essence of historic objects. And secondly, green held a very special place in the palette of early printed and hand-colored works on paper. But we still don't have a very good understanding of the types of green colorants that were employed. And this is partially due to the delicacy of the material and the low concentration of the colorants. And these all present unique challenges for conservation and research. And lastly, and perhaps the most importantly, green colorants pose a number of conservation issues. They have a tendency to discolor on their own, and the degradation products can migrate, leading to discoloration on adjacent pages. In severe cases, they corrode the paper substrate, leading to loss of material and information. And therefore, our fascination with green colorants is about addressing these crucial issues that stand in front of us. We aim to delve into the identity and degradation mechanisms of the green colorants, and we try to understand what are the key factors that drive the degradation of the green colorants on paper. And in pursuit of these objectives, we aim to harness the power of cutting-edge imaging techniques. We use these techniques to unveil the intricate details and track changes in green colorants. And this opens a window into the composition and the degradation processes. The main imaging system we use is a narrowband multispectral imaging system. And this system is equipped with a 150 megapixel phase 1 camera, a filter wheel, 2 LED light panels, and integrated software. With this setup, we can capture images at 16 different wavelengths spanning from 365 to 940 nanometers. And this system also facilitates fluorescence imaging, so which also has expanded our scope of investigation. We started our research with authentic, Sorry, I don't know what's going on. Okay, oops. No, it doesn't work. I can't go forward. I'll keep talking. So we started our research with authentic, here it is. We started our research with authentic historic objects. We are fortunate to have access to Maurits Sabbe Library at KU Leuven, who holds a large collection of early printed and hand-colored works on paper. We curated 8 of these objects, dating back to the 15th to the 17th century. And from each object, we selected 3 to 5 folios for in-depth investigation. And we tried our best to cover a wide array of different green colorants and varying levels of degradation. Doesn't seem to work. Okay, here it is. Within our selection, a 16th century classic Renaissance historical chronicle prompted really interesting research questions. And this volume features exceptional engravings with extensive applications of green colorants, as you can see on the screen. And the degradation of the green colorants becomes really apparent when we examine the versals of the folios. What really drew our attention was this recurring motif that can be found on a number of folios. The green colorants applied to this recurring motif, which are expected to be the same, exhibit different appearances, and these differences are likely to represent different degradation states. Oops. But it doesn't work. Sorry. Let me go back.
Sorry, maybe it's we will have to change the battery afterward. That is backwards and that is forwards. And please don't do this, then it goes black.
Okay.
Forwards, yeah.
No, but forward doesn't really always work. Okay. Oops. Okay. I forgot where I was. Okay. So, yes, we're here. So this observed variation in degradation states within the same object provided us a rare and unique opportunity to study the natural degradation of green colorants within historic objects. So how can we proceed to make the most of this opportunity? We selected several representative areas of green colorants with different visual characteristics in terms of tones, hues, and degradation states. And we generated reflectance spectra from both the rectal and the versal. This plot here illustrates the spectra from the versal. Although the degradation is pretty evident on the versal, we can see distinguishing between different green colorants and different degradation states based solely on these spectra is quite challenging. But when we have a look at the spectra collected from the rectal, we can clearly see two different types of green colorants. And we compared these spectra to the standards on the pigment checker, and we identified these colorants as malachite, as indicated on the screen with the blinking dots, and the other colorant was identified as a variant of green earth pigments. Notably, the green earth pigments appear to be more susceptible to degradation as indicated by their transformation to shades of brown and signs of corrosion in the paper substrate. What's more interesting is to compare those spectra to the ones collected from the same recurring motif, but on a different folio. Here's an example. The folio on the left is the one we've just discussed. And as I pointed out, the green earth pigments have undergone substantial degradation, as indicated by their transformation into shades of brown, and they have also initiated corrosion in the paper substrate. On the folio on the right, in contrast, the areas, the green colorants applied to the same areas, which are expected to be green earth pigments as well, still maintain a vibrant yellow-green hue, and the paper substrate remains intact. When we look at the spectra collected from these two folios, we can confirm that the same recurring motif was indeed colored using the same types of green colorants. And the less degraded areas were colored using malachite, and the more degraded areas were colored using green earth pigments. I like to point out that there is a slight, for the green earth pigments, there is a very subtle increase in reflectivity in the near infrared region, which is likely to be an indication of degradation of the green earth pigments. A more evident indication of their degradation can be obtained under fluorescence. So between the green earth pigments that were applied to these two folios, we can see there is a significant contrast in the fluorescence intensity beyond 590 nanometers when stimulated by 450 nanometer light. And degradation of the green earth pigments is likely to have induced the significant reduction in fluorescence intensity. So these observed changes in optical properties offer us an opportunity to develop an innovative analytical tool for conservation and research for characterizing the natural degradation of green earth pigments. So we currently focus on processing and analyzing the multispectral imaging data. In the next step, we plan to harness the power of artificial intelligence to unlock deeper layers of insights into these images. We also plan to gain more insights into the chemical compositions of the green colorants by using other types of non-destructive and microdestructive methods, such as the X-ray Florescence spectroscopy. And additionally, we are committed to conducting a series of accelerated degradation experiments. We believe these experiments will help us to validate and expand upon the observations we make from the historic objects. I would like to take this opportunity to thank all my colleagues at Watteeuw for their generous support to this research project. And thank you for your attention. Please do feel free to reach out and share your comments. We would always be very happy to engage in discussions with you. Thank you.